we're going to start talking about exponent rules. So our goal over the next 3 days, we're going to talk about 6 different exponent rules that will help us simplify our expressions. So we are going to be using the book pages. Things I want you to review real quick. If I gave you 3 to the 4th power, keep in mind this 3 is our base number and the 4 is our exponent. And the entire thing is called a power. All right, so make sure you know that vocabulary as we start. So we're going to talk today about icebergs. We know that icebergs, we can see the top. It also sunk, an iceberg sunk the Titanic as well, right? And on the bottom, you can kind of see the shadow down here. There's a lot more to it. And the same thing goes for exponent rules. It's going to be on the surface pretty simple, but there is a lot more to it when we start adding things, and that's where we're going to go. The smallest size iceberg is called a growler. It is found floating in the ocean. This one is in Greenland, and its volume above the water is approximately 27 cubic meters. Now, why is this important? Well, we're going to use this 27 cubic meters, and we're going to relate it back to our exponents. So if we have 2 icebergs are near this growler, one has a volume 3 to the 4th times greater, and the second has 2 to the 8th times greater. Which iceberg has a greater volume? Guys, these are powers, 3 to the 4th power, 2 to the 8th power. Now, if we want to know which one has a greater volume, what do you think we need to do? What does this mean, 3 to the 4th power, if we expand it? Great. 3 times 3 times 3 times 3. What does this one mean? Yeah, 2 times itself 8 times, right? So the whole purpose of a power is the little guy tells the big guy how many times to multiply by itself, right? So this says we multiply 3 times itself 4 times, 2 times itself 8 times. Now, the beautiful thing about our calculator is that we can do exponents in our calculator. And if you don't remember how, down here by the 4, we call this a caret. And that is going to help us go to an exponent that is not 2. So we can say 3 to the 4th power is 81. So this particular growler is 81 times the size of the one in Greenland. 2 to the 8th power is 256 times larger. So which iceberg has the greater volume? Well, the 2 to the 8th, because even though the base number is smaller, we're multiplying it by itself more times, so it's going to get larger pretty quick. What is the meaning of 3 to the 4th and 2 to the 8th? Why do you think the exponents are used writing numbers? Well, we already wrote what it means, right? We wrote these out, so we don't need to write that again. And why do we think exponents are used when writing numbers? They are used to represent numbers based on the same factor, right? A factor is the number that we use to multiply, right? So this is a repeated factor, 3 times 3 times 3 times 3. Does that make sense? Do we have any questions so far? All right, suppose the original growler's volume underwater, because remember, on an iceberg, you have a top part and a bottom part, is 9 times the volume above. Well, what was the volume above the water on that growler? 27. So how much ice is below the surface? What do you think we need to do here? 27 times what? Times 9. Use your calculator. 27 times 9, just because sometimes we're tired. 200. So this is 243 cubic meters. That's the part that's below. So when we talk about exponents, we're talking about repeated factors. It's asking us to take what we wrote here, 27 times 9, and write it with powers of 3. Well, We know that 9 is 3 squared, right? We learned that in 7th grade with Pythagorean theorem. How do we write 27 as a power, or with a factor of 3? 3 times what? If we do 3 times 3, we get 9, right? So 9 times what is 27? 3 again. So we would write 3 to the what? 3 to the third power. So if we wanted to represent 243 with a factor of 3, what do you think that would be? Use your calculator. We can say 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, oh, there it is. How many 3's did we have? 1, 2, 3, 4, 5. So we could even represent this as 3 to the 5th power. Our goal today is to discover the rule so that we don't have to use the calculator every time. What is this? So here's where it comes in. What is the relationship between this left-hand side, 3 to the 3rd power times 3 to the 2nd power, and the right-hand side, 3 to the 5th? Do you see any kind of a relationship or a pattern? What do you think? Oh, so the exponents were what? The exponents were added, right? We can say 3 plus 2 equals 5. Does anyone have any questions about that? On this next table, or next page, we have a table, and this is going to help us find our pattern. It gave us 2 squared times 2 to the 4th. So notice here is 2 squared. Here is 2 to the 4th. So we have a repeated factor of 2, meaning 2 is our base. And we have 1, 2, 3, 4, 5, 6 of them. If we wanted to expand out 5 to the 3rd, what would we write? 5 times 5 times 5. And then 5 squared is 5 times 5. So how many 5s do I have? 5 to the 5th power. We can do the same thing with variables, right? X to the 4th is 4 x's. X to the 7th is 7 x's. 4, 5, 6, 7. How many x's do we have multiplied by themselves? 11. And we even have a's. So if I have 6 a's, 1, 2, 3, 4, 5 times 2 a's, how many a's do I have multiplied together? A to the what? A to the 8th. So our rule says that as long as we have like bases, meaning that big number, what do we have to do with our exponents? We just need to add them. So if I have a to the m times a to the n, then I am going to take and I'm going to keep that base and I'm going to add my exponents. Okay? All right, on this next question, we do have fractions, but we're not going to be fraction fraidy cats. We're going to follow this rule. We have like bases of x, so we need to add our exponents. We can't really write out 3/4 of x and 5/4 of x, but we can write our rule, which says add our exponents. So I'm going to come up here, I'm going to write 3/4 plus 5/4. Now, don't stress out. What is 3/4 plus 5/4? It's 8/4, which is just 2. And we're done. So don't stress about that. All right, just because there's fractions, and if you needed to, you could even put the fractions in the calculator. When we talk about density, this is a little bit of science here for you. Density equals mass over volume. The density of an iceberg is determined by dividing its mass by its volume. Suppose the growler had a mass of 59,049 kilograms and a volume of 81. If we want to know the density, we would just do mass 59,049 over volume 81, and we can use our calculator because that's a big number. 59, 0, and we say 81. We get 729. And when we write our density, it is kilograms per cubic meter. So now they want us to take these numbers and write them in powers of 9. Well, let's think about what we know. Our volume is 81. How do we write 81 as a power of 9? What times what is 81? 9 to the what? 9 to the second power. If I want to get, we can use our same strategy as before. If I say 9 times 9, I get 81. There's 2 of them, 3 of them, 4 of them. So 5, 9 to the 5th gave me my 5949. Okay, so we can say 9 to the 5th. Now, I wanted to get 729. Well, I already got 729 here. That was 1, 2, 3 nines. Do you see how I got that? So if I'm going to represent this with powers, I could write this same exact problem as 9 to the 5th over 9 squared equals 9 to the 3rd. So what is our pattern now? We are subtracting. The exponents are subtracted. So if we're multiplying, we're going to add our exponents. And if we're dividing, we're going to subtract them. Does that make sense? So when we look at this table on the next page, it's going to show us why, in fact, we're subtracting. So if we have 2 to the 5th over 2 squared, guys, what happens when you divide a number by itself? You get what? We get 1. So really, so this becomes 1 times 1 times 2 times 2 times 2. So we get 2 to the 3rd. Because that's what's left over. We don't need to write 1 times 2 to the 3rd. The 1 times is implied, right? So if we wrote 5 to the 8, 5 times 5 is that 4, 5, 6, 7, 8 over 5 to the 6, 3, 4, 5, 6. Then I know that 5 divided by 5 is 1. So these all become 1. And we're left with what? 5 to the 2nd, or 5 to the power of 2. Okay, we don't need to write the 1 times. The same thing will happen for variables. Don't be like, oh, I have no numbers, it won't work. Yes, it will still work because a divided by a is 1. And we're left with a squared, or a to the 2nd power. Same thing with x's, 3, 4, 5, 6, 7 over 1, 2, 3. So I get my 1s. How many am I left with on my x's? X to the 4th. So when we write our rule, as long as our bases are the same, and remember when I say bases, I mean the big number or the big letter, then all we're going to do is subtract our exponents. If I looked up here, 5 minus 2 is 3, 8 minus 6 is 2, 3 minus 1 is 2, 7 minus 3 is 4. Do you see that relationship? And the reason that happens is because we can see that they cancel. So if you are okay writing it out, that's fine, especially if you forget the rule, but feel free to use this shortcut if you need to. So I would like you to try number 14. All right, so when you did this, we can use that shortcut, 11 to the 3rd minus 2 to the 3rd. We know we already have a common denominator, so it is a to the 9 over 3 power. What do we know about 9 over 3? A to the 3rd. Okay, so not too bad. Sometimes we have coefficients. Coefficients, notice, do not follow the pattern. Look at this, 2 times 5, and they got 10. But then they did add the exponent. So we're going to do a little bit of combining, not a lot. So we're going to turn the page. We're going to look right here at the try these. Guys, if it helps you, and I would strongly suggest till you get the hang of it that you write the rules out. Guys, our coefficients are just normal. 4 times a negative 2. this x does not have an exponent, we're going to put a 1 there. We never write an exponent of 1. Let me zoom in a little bit so that it's bigger. All right, so if there's no exponent, there is an exponent of 1. It's just like that invisible one we've had before. So I have like bases being multiplied, so I'm going to say x to the 1 plus 2, because when we multiply, we have to add the exponents. And y to the 4 plus 5. Does everyone understand how we set it up like this and why? Are we okay with that? Then you can go ahead and do your math. If it helps you if this is a little confusing, we could come over here and we could say, I have x to the first and I have y to the fourth, and I have x squared and I have y to the fifth. So I can see that is why I'm adding these exponents. So I have -8. How many x's do I have now? X to the, what's 1 plus 2? 3. I can also see that here. X to the third, y to the what? Y to the 9th. Okay, so that's how you can utilize those rules. Now, if you are more comfortable writing it out like this, then by all means, expand it out so you can see what's happening, and that is fine. But keep in mind that these coefficients, these regular numbers that are not the same, they are not the same base, you can't do that with. So let's look at this one. So again, these regular numbers, right? They don't match. We just have 2 over 4. We're just going to write it over here. We're going to put a 1 on this A and on these C's. If it helps you to write it out, you can. Over, I have 1A, I have 2 B's, and I have a C. Or you can use the rule. You can say A to the second minus 1, because we're dividing. So that told us we needed to subtract. B to the 5 minus 2, C to the 1 minus 1, and you can see that's what's happening up here, because A over A is 1 whole. So how many A's do I have total? A to the what? To the first power. You just write A. Look at my B's. How many B's am I left with? B to the 3. Because 5 minus 2 is 3, or you can see it up there. And what about my C's? Am I left with any C's? No. 1 minus 1 is 0. The C's disappeared, and that's okay. What about this 2 over 4? What do we know about 2 over 4? It's 1 over 2. Okay? How do we feel about that? All right, last one. Then I'm going to have you do some practice. So look right here. Coefficient, coefficient, coefficient. We're just doing regular math with that. So we're going to say 6 over 18 times 2. Guys, you can put that in your calculator. We'll look at that. What needs to go on this x down here? X to the what? X to the first, and then we're going to have 1's here and 1's here. If we wrote this out, we would have y, and we would have x's, 1x down here, times, and then we would have an x and a y up here. Can you see that? How many y's do we have? 4. Guys, you could even put a 1 here. How many x's are we going to have? Be careful. None. These are going to cancel. So I'm going to show you how you can use that shortcut. These are, all of this is the numerator. So that means we're multiplying. That means we're adding, because they're all on the top. So we have y to the third plus 1. Now this is in the numerator and this is in the denominator. What are we going to do with those? Because that's technically dividing. What is the rule when we divide? We're going to subtract. So let's see what happens. We said we have 4 y's. Our x's go away, right? 1 minus 1 is 0. Use your calculator here. What is 6 over 18 times 2. Michael got 2/3. Yes, great job, sir. So we get 2 over 3 y to the 4th. Okay, so this is a little bit of that combining I was telling you about at the beginning. Here's what I'm going to ask you to try for me. Down here, I would like for you to try numbers 15 to 21. 22 is a bonus. Okay? Now, I would strongly suggest you, with numbers, you can always check it with your calculator. I would also suggest that you are making sure you're setting them up. Show me the steps so you can see what's happening. If it helps you to write them out, then do that. You do have video notes tonight, so make sure you do those as well, and we'll look at all of this tomorrow when you come in.